Okay, we're going to continue looking at rational functions, and this time we're going to add a couple of little wrinkles to it. One of those is in addition to finding the domain or any restrictions in the domain of a rational function, as well as the vertical and horizontal asymptotes, if there are any horizontal asymptotes. We're also going to add to this discussion finding the X and Y-intercepts of our rational function. So let's go over our rules very quickly. If we're looking for a vertical asymptote or what may be a hole, although we're going to deal with holes later, we're going to factor the denominator and the numerator. We're going to set the denominator, the factors of the denominator equal to 0 and solve. And when we do that, when we solve for x after setting the factors of the denominator equal to 0, that's going to determine our vertical asymptotes. And if we should have any holes, it would be because we got a factor in both the numerator and the denominator, but I don't believe we're going to find that in what we're doing at the moment. Horizontal asymptotes, we're going to consider the highest power of x in both the numerator and the denominator. That's what we're going to look for. We're going to ignore everything else. If the numerator is less than the denominator, then our horizontal asymptotes is y equal to 0. If the numerator is greater, if the highest power, I should say, of the numerator is greater than the highest power of the denominator, then will not be a horizontal asymptote. But we will discover later, we may in fact have a oblique or a slant asymptote. And if the numerator is equal to the denominator, then our horizontal asymptote is the ratio of the lead coefficients of the variable raised to those highest powers. Now, when it comes to determining x and y-intercepts, we should already know that if we want to find the x-intercept, we substitute 0 for y, or f of x, into the function and solve for x. That would give us our x-intercept, and if we want to find the y-intercept, we set the value of x in the function, all the x's equal to 0, and solve for y. So let's move over here to the next slide, and we're going to make our algebraic calculations, and then we will compare that with what we see on the calculator. Okay, let's see what we got here. We're asked to find for each function, determine any vertical and horizontal asymptotes and intercepts, then graph the function and state its domain. So we have a function here, h of x equals 2 over x squared plus 2x minus 3. So I think I'm going to tackle the vertical asymptotes as well as any restrictions to the domain. I only got a 2 in the numerator, so that's going to cool. So I'm going to be looking therefore at the denominator, and in order to determine the vertical asymptotes, I'm going to have to factor this denominator, and I got a strong suspicion that's going to give me 2 vertical asymptotes. So let's factor this x squared plus 2x minus 3. It does really, really help if you know your multiplication tables. But if I'm going to factor x squared plus 2x minus 3, then I can get x plus 3 as one factor, and the other factor is x minus 1. Okay, if I FOIL that back, x squared plus negative minus 1x plus 3x minus 3. Combine the like terms, I end up with x squared plus 2x minus 3. You can FOIL it back on your own. Now I'm going to set each factor equal to 0. And that's going to give me vertical asymptotes. I'm going to have 2 I can see already. So I've got x plus 3 equals 0. X equals negative 3. And in my second factor, I've got x minus 1 equals 0. And x then is equal to 1. So let's go ahead and state our domain and determine our vertical asymptotes. Well, my domain is D equals x such that x does not equal negative 3 or 1 But otherwise, x is an element of all real numbers. So then my vertical asymptotes, I'm going to write it like this. I'm going to say VA at, got a vertical asymptote at x equals -3 and x equals 1. Now, what about my horizontal asymptotes? Well, let's see. Even though this doesn't have x to the 0 power, I could actually assume that because x to the 0 power is just going to equal 1. And so my highest power of a variable is less in the numerator, is less than the highest power in the denominator. And so by rule, then the horizontal asymptote is going to be at y equals 0. So my horizontal asymptote is at y equals 0. Got to go back to those rules if you don't remember it. Now that leaves me with the intercepts. So if I want to find the y-intercept, I'm going to set all the x's equal to 0 and solve for y. So let's say I got y equals 2, and I'm going to substitute in for 0 all the x. Well, I got 0 squared plus 2 times 0 minus 3. Well, 0 squared is 0. 2 times 0 is 0. Make that a little bit better. 0. Now it looks like an 8. So I got 0 plus 0, -3. And so I've got a y-intercept at 2 over -3, or -2/3. Now, what about my x-intercept? If I want to find my x-intercept, I set y equal to 0. Solve for x. So now I've got 2 over x squared plus 2x minus 3. Now, since that quadratic equation is in the denominator, if I'm wanting to solve for x, well, I'm going to multiply both sides of the equation by the quadratic, x squared plus 2x minus 3. But when I do, I'm going to be multiplying it by 0, which is just going to give me 0, and 0 equals 2 is not a true statement, and therefore I do not have an x-intercept. So there is no x-intercept. Now let's jump over here to the calculator and see if we can find that, in fact, we do have a vertical asymptote at -3 as well as at -1. And we've got an a y-intercept at -2/3, but nowhere are we crossing the x-axis. Now, here's what's going to happen on that graph. Let me just try to draw that right here. Here's what I'm expecting. I'm going to have a vertical asymptote out here. I'm going to have a vertical asymptote out here. Now, I'm not sure if my function is going to swoop like this or swoop like this on this side, and it could be over here, it could be over here. But I'm also expecting something in the middle. This I'm not sure of which side, but I am expecting something to come in here, maybe like that, where it's crossing that y-axis. It'll be at -2/3. It crossed down here. Okay, we'll see. All right, we're over here at the graph. And let me move that cursor over. It's not blinking right at our heads. But anyway, I have gone ahead and entered the function equation. I've got 2 over, and I put that quadratic in parentheses, x squared plus 2x minus 3. So I've got that entered. Let's see what happens with this graph. Oh, okay. Fooled me there in the middle. All right, so I can see right here I do have a vertical asymptote. Look, this graph does not appear to be crossing the -3. I got 2 places right here where it's zooming in. And here I got a vertical asymptote. Kind of trace this back down here at 1. So that looked good. I've got a horizontal asymptote. It appears right around here at 0. And what I didn't expect was this upside down parabola right here. And I expected something in the middle. I thought it may have more of a swoop curve. Anyway, so there we go. I got my vertical asymptotes. Those are restrictions to my domain. I've got horizontal asymptote. Let's just peek at the graph for just a second. I mean the table, I should say. Okay, I can see right here at -3. I got an arrow, which is what I would expect. It's undefined at that level. And at 1, I can see I've got another arrow right here. I can see it's getting close to 0 right here before the arrow, and then as it's coming back out, it's close to 0 again, but staying below it. And same thing here, where y is not crossing the barrier of that horizontal asymptote at 0. And I didn't look at my y-intercept. I do see a y-intercept right in here, and I can't tell exactly where that is, but it looks like it's probably at negative 2/3. Okay, there we go. Not bad. All right, let's look at our second example. This is over on page 133. This is guided practice 2B out of example 2. Rational functions. Again, we're being asked to determine any vertical and horizontal asymptotes, as well as the x and y-intercepts, if there are any, and then graph the function and state its domain. So I've got a function here, n of x equals x over x squared plus x minus 2. And not much I can do with that numerator, but I can factor the denominator. And so I got x plus 2 times x minus 1. I believe if I FOIL that, I'm going to get x squared plus x minus 2. I'm going to set each one of these factors equal to 0. So I got x plus 2 equals 0. And x equaling negative 2. I'm expecting a vertical asymptote and a domain restriction at negative 2. And I got x minus 1 equals 0. And solve that. So x at 1. Let's go ahead and state our domain. I got our domain equals x such that x cannot equal negative 2 or 1. But other than that, x is an element of all real numbers. And should have a vertical asymptote where x is equal to negative 2 and x is equal to 1. All right, let's see. Before we get into the intercepts, let's think about the horizontal asymptote. Well, this is x to the power of 1 right here. And that is less than x squared. So my rule is if my highest power of my numerator is less than the highest power of my denominator, then I should have a horizontal asymptote at y equals 0. Again, I'm going to have two vertical asymptotes. Something's going to be swooping in on the left hand and the right hand side, not crossing the y-intercept, but there's going to be something else going on in the middle. Let's see. Let's think about, let's find the x-intercept first. So if I want to find the x-intercept, I'm going to then set y equal to 0. Let's see, I may do that right here. Y, I should just put 0 here. So I've got 0. We're looking to find the x-intercepts. X over x squared plus x minus 2. And just like we saw in the last example, if I take that quadratic in the denominator, multiply both sides of the equation by that, so it'll cancel out on the right-hand side, well, then I'm going to end up multiplying it by 0, and I'm going to be left with 0 equals x. So I'm going to have something with an x-intercept at 0, or an x-intercept x equals 0, probably the way I should write it. And let's see, what about the y-intercept? Well, if I'm going to do the y-intercept, I want to set all the x's equal to 0. So I got y equals, substitute 0 for x in the numerator, 0 squared plus 0, substituting 0 for x, and negative 2. But that's going to leave me with 0 divided by negative 2. So I'm going to have a y-intercept where y is equal to 0. So I'm looking for probably in that middle section, I'm figuring, where I'm going to see a portion of the graph that is going to intercept right there at the origin, x equal to 0, y equal to 0. All right, let's go graph it and see what we got. Okay, so here we got our rational function entered into the y equal. I got x over x squared plus x minus 2. So there's my rational function I'm looking at. Let's go take a peek at the graph. All right, so swoops down. Yes, okay, there we go. All right, let's see what we got right in here. Well, it does appear I've got a vertical asymptote running right down here along where x is equal to -2. Doesn't seem to any of this seem to be crossing that. And I got another vertical asymptote right here at x equal 1 swooping through. And on this left-hand side, this quadrant 3, I can see that it would appear I've got a horizontal asymptote at that location because it doesn't want to seem to get above that y-axis. And over here in quadrant 1, I see the same thing. It's swooping down this way as x is going towards infinity. It doesn't appear to want to cross that y-axis, so I got a horizontal asymptote on this end. But here in the middle, it comes in here, zoom, and I can see that it does intersect at the origin where I have an x-intercept at 0 and I have a y-intercept at 0. And hey, that's kind of what I was looking for. Didn't necessarily know it was going to come swooping through here like this, but I knew something was going to happen there in the middle. Let's take a look at our table just real quick. And I can see when x is -2, it's going to be y is undefined, x is 1, y is undefined. But I do have one little section there of the graph, there at the origin, where it does cross, and I've got intercepts at both locations. And as x is going towards -infinity, I can see that this is getting smaller and smaller and smaller. But if I were to run that table up, I don't believe it's ever going to cross 0 at that level. It is going to cross here between -2 and 1. We know that. And then here going out from where x is equal to 2, going out towards infinity, again, I see the value getting smaller and smaller and smaller as it's approaching that horizontal asymptote at that level. Okay, well, there we go. We got more to do.